Welcome to the Year 13 Mechanics 2 Power and Force and Acceleration support session. This session we're going to look at one specific question from a past paper. And hopefully that will help you while you prepare for your exam. Let's have a look at this question that we're going to be looking at. So here we have a car of mass 1,200 kilogram pulls a trailer of mass 400 kilograms up a straight road, which is inclined to the horizontal at an angle of alpha, where sine alpha equals 1/14. So let's put our trailer, our car. Our trailer is 400 kilograms, our car is 1,200 kilograms. Sine alpha is 1/14. Now, therefore, this trailer has a gravitational force down of 400 G. The car has a force down of 1,200 G. The trailer is attached to the car by a light inextensible tow bar which is parallel to the road. So there is no mass on the tow bar at all. It's light and inextensible. The car's engine works at a constant rate of 60 kilowatt. The power is 60 kilowatt. So that's right, the power is 60,000 watt. The non-gravitational resistance to motion are constant and of magnitude 1,000 on the car, so there's a 1,000 Newton on the car and 200 Newton on the trailer. At a given instant, the car is moving at 10 meters per second. What is the acceleration of the car at this moment? So what is acceleration? That's what we're asked to find. All right, so let's apply our formula for the fact that power will equal our attractive force times our velocity. So 60,000 will equal our attractive force times 10, which is our velocity. So let's divide that by 10 to get our attractive force, and we end up getting 6,000 Newton. Now we have a 6,000 Newton pull, and we're after still after the acceleration. So now we have a force up of 6,000 and forces down, and let's get our resultant force equals mass times acceleration. So our force up is 6,000. Our force down, we have a combined mass of 1,600 kilogram, therefore we have 1,600 G force down at an angle of, and this would be cos of this angle, or sine of the complementary angle. And then we have a combined resistance force of 1,200 newtons, so we add the 1,000 plus the 200. That will equal our mass, which is 1,600 times acceleration. Okay, so let's get our calculator out, do this calculation. So we have 6,000 minus 1,600 times G, which is 9.8, multiplied by sine of alpha, which is 1/14. And then we have to minus 1,200. Let's just check that. We've got a lot of decimals. Let's just go through 6,000 minus 1,600 times 9.8 times 1 divided by 14 minus, okay, so we did have an error. I'm not sure where it was. So we've got 3,680. 3,680 is our resultant force. That equals 1,600 mass times acceleration. Therefore, our acceleration will be 3,680 divided by 1,600. So that will give us 3,680 divide 1600. An acceleration of 2.3 meters per second squared. So let's put that here. Our acceleration is 2.3 meters per second squared. Part B, what is the tension in the tow bar at this instance? So we've got a tension here in the tow bar. So let's look at this system alone. So we've got the force up, which is tension, force down, which is 400 kilogram gravitational force times sine of alpha, and then our resistant force of 200. And that equals mass times acceleration, which is 400 times 2.3, mass times acceleration. Therefore, our tension will be, let's just do this calculation. Our tension, let's just write, it will be 400 times 2.3 plus 400g sine of alpha and 200. So let's just do this calculation here. So we've got 400 times 2.3 plus 400 times 9.8 and divide that by 14 plus 200, which is a tension of 1400 Newton. So let's put here the tension in the tow bar will be 1400 Newton. Finally, what is if the tow bar breaks when the car is moving at 12 meters per second? Now at that point, this tension ceases to exist in the tow bar, and we've only got the gravitational force down, 400g, and 200 Newton down. And that is our resultant force. So F times S will be the change half in kinetic energy. So we end up with half mv squared minus half mu squared. So let's have a look at this. Our force will be negative 200 plus the 400g, and that's a negative 400g sine alpha times s will equal our final velocity of 0 minus half times m and our initial velocity of 12 meters per second. So let's do this calculation. In this bracket we have a negative 200 and a negative 400 times 9.8 divided by 14. So we've got a negative 480s. So let's put here negative 480s equals, and we've got 0 and 0.5 of 400 times 12 squared, which is 144. 28,800. So we've got 0 minus 28,800. Therefore, our S will be negative 28,800 divide negative 480, which equals, two negatives make a positive, 28,800 divide 480 equals 60. So let's put that equals 60 meters. So our distance traveled after the tow bar breaks will be a further 60 meters. Okay, so we had a part A, a part B, part C question. Let's have a look at our solutions. Part A, we've got A equals 2.3 after you've looked at mass times acceleration being the resultant force. And so we've got 2.3, so we are correct. Part B, they've said the tension just on that 400 kilogram system will be 1400. So part B, we've got 1400, so we're correct. And part C, let's just go down to the next slide. Oh, didn't I put that in? All right, so part C, we'll just have to have a look at the marking scheme. I did look at it earlier. If you look at the marking scheme, if you find this question, you'll find that the distance is 60 metres, and I'll add that to a note of the video as to, I might get a little picture and or a little post and say which particular exam this came from so that you could check that question. All right, well, I hope that you can find similar questions like this and practice them so that you're prepared, so that you can just go ahead and work this math as immediately when you see it. And until I talk to you again or see you, stay happy.